right, our next presenter, I'm fortunate enough to also call a friend. We've worked together for a number of years while we were at NetApp up until, yeah, and but he is Andrew Sullivan, and he's going to give us one of our technical talks on containers, right? Yes, sir. Awesome. Well, with that, I will pass it on.
Good morning, everyone. There we go. Good morning, and well, welcome to, what is this? The stock room, right? So I'll let the traffic die down a little bit while I do my introduction. So my name is Andrew Sullivan. I am a technical marketing manager, which means that I have been 2/3 lobotomized. I apologize in advance to any marketing people or managers. So that being said, I have spent the vast majority of my career being in ops. I started out in the military, of all things, where I did help desk support, where I did server support, where I did a lot of other things. And that bled into becoming a system administrator and a short stint as a developer. Sadly, I was terrible at being a developer, and that's why I was only there for a short period of time. And then eventually I made my way into the vendor side. And the vendor side is really, really interesting because it's always really fast moving. And it's fast moving because of, well, you all. Because you're all doing different things. You're all constantly changing, and you all have different challenges. It's true that everybody is a unicorn when we look at our customers. I had to throw in a unicorn reference. So what are containers? I like to talk about containers because, well, it's something that is, if we look just below the surface, they're not new. What we call a container today is 12 years old. It was introduced to the Linux kernel in 2006 by Google. But it's really even older than that. The premise behind a container is based off of things like BSD jails, Solaris zones, things that were born in the 80s and the 90s. So why do we hear about them so much today? Why have they suddenly come to this forefront? Docker was founded roughly 4 years ago. And actually, they pre-exist that. That's just when the name Docker came about. So why have containers become such a thing? And yes, we will talk a little bit about the technical what is, how does a container, but really we want to talk about the why. Why are containers so prominent today? Why are containers continuing to grow in popularity? Why do we see them more and more and more going forward? And the way that I like to start this conversation is by talking about how we deploy applications. We're all operations people here, right? Is there any developers in the room? One? I'm so sorry. It's just, you shouldn't have admitted that. You might be in trouble now. So when we deploy applications, how is this done? And this process has been largely the same for the last 30 plus years. The business comes to IT and they say, hey, we need to deploy application Y. Doesn't really matter why. Most of the time we don't ask why. We just say, okay. And we identify some sucker or team of suckers and say, hey, you now own application Y. From end to end, soup to nuts, you own that application. And maybe they go out and they take some training and they deploy a test instance and they figure out the best practices and they go through all of these processes to ultimately deploy that application, however it should look. But the problem with this is, what happens after that? Most of the time, we ignore that application until it breaks, until Josh's beeper goes off. And then we go back and we fix whatever was broken. Maybe every 6 or 12 or 18 months, whatever that vendor release cycle happens to be, we go back and we apply some updates or some patches. But that's not the way things work anymore. Does anybody remember 2008? Kind of a big year, right? There was a lot of things happening in 2008. So the first thing that I'll bring up about 2008 is that was when ESX 3.0 was released. Any virtualization people in the room? You remember ESX 3.0? That was when we saw this, right? It was enterprise ready, NFS data stores, live migration, all of this other stuff was suddenly available to us. But there was this other thing that happened in 2008. Does anybody remember what that was? Right? Probably the first thing that sprang to your mind when I said 2008. Exactly, the Great Recession. So it wasn't so much that virtualization had this quantum leap ahead, it was suddenly we had this external driver. We had this thing that was pushing us where we didn't want to spend CapEx purchasing hardware anymore. Suddenly the business wanted to spend money on other things. I like to call this my oxymoron hoodie. It's a virtualization hoodie. So, but there's one other thing that happened in 2008. Something that a lot of people don't realize. That was the year AWS launched. AWS is now 10 years old. Anybody pay attention to AWS reInvent last week? Some of the cool stuff that they got coming out there. AWS has fundamentally changed the way that applications work. And it's not just AWS. Of course, there's Azure, there's Google, and on and on and on. So what I want to talk about today, where I'm going to lead this to, is how applications have fundamentally changed and how containers are ensuring that we remain a part of that conversation as the on-premises IT operations teams, and why it's important to pay attention to that. So first and foremost, what is it that what is it that developers care about? A lot of times we talk about DevOps and how in order for a successful DevOps implementation to happen, we need to have everybody being measured by the same thing, deploy faster, to make features happen faster, et cetera. And ultimately, this is what developers care about. Developers are asked by the business, the applications teams are asked by the business to deliver those features, to fix those bugs, to make the application do whatever it is that the application does. We need to sell more widgets. We need to do whatever it is that the business does better, faster, stronger, harder. And in order to do this, developers like to have choice. They like to be able to select that newest, fanciest programming language that nobody's ever heard of because, well, developers are prima donnas, no offense. Because it makes their life easy. The same reason that I got a chuckle out of Josh's Google searches, the bottom one that said, good system administrators are lazy. Does anybody remember that phrase? Remember that way back 10, 15 years ago? It was about automation. Good system administrators take a simple task and they automate it so that they don't have to do it anymore. Developers want the same thing. But the problem is, often this is in contrast to what we as operations teams want. Operations teams, I know when I was a storage administrator and a virtualization administrator, I was measured by how efficiently, i.e. how cheaply, I could provide the maximum number of nines to my applications. We want predictability. We want stability. We want to ensure that human error or machine error doesn't lead to catastrophic failure. Does anybody remember ITIL? Right? ITIL was a whole framework around eliminating human error out of the IT process. That's why there's so many change advisory boards and people with all those different hats that they had to wear and all these other things. We want to eliminate human error. So operations teams want things to move slowly. Operations teams want to control resource consumption. Developers don't. When I want to deploy my application, I don't care about the infrastructure. I don't care if it's running on Intel or AMD processors. I don't care if it's running on Lenovo or IBM. Well, IBM doesn't have servers anymore. If it's running on Lenovo or Dell servers, it doesn't matter to me. I just want to be able to deploy. And importantly, I want to be able to not have to get in an argument about it. Josh mentioned that we worked at NetApp together. There was the way that I tend to describe this is a day in the life of a storage request. I'm an application guy. I say I need 10 terabytes of storage. I need it to be super fast. I need some flash storage. So I put in that help desk ticket, or whatever that process happens to be, and it lands on the storage administrator's desk. And the first thing that he's going to do after he finishes laughing at me is start an argument. What do you mean you need 10 terabytes of storage? I know you only need 1 terabyte of storage. And you're going to get 500 gigabytes, and you're going to be happy about it. And so we have this argument. We have this back and forth that lasts days or weeks because that guy goes on leave all the time. He's been at the company for like 65 years. And eventually, I get my 300 gigabytes of storage because I lost that argument, and I have to deal with that. But the problem is that didn't change the request. It doesn't change the fact that, no, I really need 10 terabytes of storage. So what happens in a lot of modern organizations is that developer then simply goes to AWS. As they're walking away, shaking their head and rolling their eyes about that stodgy storage guy, right? I don't work for a storage company anymore. I used to make fun of storage guys as being the new Oracle DBAs for the stodgiest, grumpiest people in the room. So as they're walking away, rolling their eyes, they're getting out their credit card. And is it shadow IT if the only people who don't know about it is the operations team? The whole rest of the business knows about it. They endorse it. They support it. They think it's great. The operations team says, shadow IT. So it doesn't invalidate that request. When I was in the military, I used to tell my Army guys, why do we have a culture of no? Why is the first response to every request no? So we have to find a way to change that. So why is this important? So the applications themselves are changing. I like to call this my slide of semantic satiation. Does anybody know that term? You ever heard of semantic satiation before? It's where you hear a term so many times that it loses all meaning. I usually use the term DevOps as an example. We've heard DevOps for literally a decade now. It means something different to everyone. Eventually we all converge, but if you hear it enough times, it's just this abstract thing that doesn't really mean a lot. So our applications have evolved. The way to look at this is it reads from left to right, top to bottom. So if we look back at most applications, the largest applications that we support as an operations team, generally speaking, they follow this pattern across the top line. It's a waterfall development or waterfall release cycle. Every 6 months, every 12 months, whatever that happens to be, I get a new release. I get an update, whether it comes from a vendor, whether it comes from an internal applications team. It's monolithic because all of that gets updated, gets managed as a single entity. It doesn't matter if there's 5 servers that participate in that, they all get updated at the same time. Typically, I deploy these to physical or virtual servers, and they reside in my on-premises data center. But what happened in 2008 was that this started to change. See, suddenly I could go from weeks to months of getting a new server, and that server existing until it quite literally died in the rack. I can now create and destroy virtual machines in days, or minutes if I'm using those hyperscalers. So our applications brethren, our developer brethren, took advantage of this. They also were forced into this because if I'm deploying to a hyperscaler, some percentage of that is going to be down at any point in time. Does anybody know what the guarantee or the availability guarantee is for AWS? They don't really publish it, but the generally accepted number is 3 nines. So my application architecture had to change to compensate for some percentage of the application being down. This is in stark contrast to us operations guys who 5 nines is a bad day. Usually we strive for 6 nines, again, as cheaply as possible. So applications started to adopt, while we have N tier on the slide, I like to call it service-oriented architecture. We're breaking up our applications into components, and we manage each one of those components separately. They interact. One of the greatest things Jeff Bezos ever told the AWS team was everything is an API. There is no back-end communication. There is nothing that happens that doesn't happen through an API. So we have these service-oriented architectures. We start seeing VM sprawl. How many people remember VM sprawl? Where we start going and deploying more and more and more VMs instead of 1 or 2 physical servers to do the same job. This is because we were more granularly scaling. We were compensating for the failure domains that happen inside of our hyperscalers. And ultimately, today, we end up at this bottom row, where we have things like microservices, where we're taking that service-oriented architecture to the next extreme. We're breaking it up as small as we can. But what's important here is containers, that topic of this particular session. So containers are different in a lot of ways. Containers allow me to package up my application and move it around. As an application team, as a developer, it means I don't have to care what's happening underneath anymore. I don't have to care whether it's running on a VM locally, a physical machine locally, a virtual machine in a hyperscaler cloud, whether it's running on my laptop. It doesn't matter. I can stop worrying about that. So containers decouple the application from the operating system in the same way that virtualization decouples the operating system from the hardware. So what does this actually look like? So I'm not going to go way down in the weeds. Right? We can scratch the surface. Containers are namespaces. Namespaces provide nothing more than process-level isolation with the rest of the system. I instantiate a process. Bash, Perl, Python. Who uses Perl anymore? Is Perl 6 released yet? Wasn't it coming out in like 1998 or something? Could be a binary, Java, right? Entire JVM. I take that process and I isolate it from the rest of the system at the process level. I can attach other things, a new network stack. Hey, you get your own separate connection to the network. I can attach a separate file system. You have a whole new file system inside of there. And it looks like, well, whatever I want it to look like. Maybe I have a statically compiled binary. It's just that one binary inside of there. Maybe I'm using Python, and I have not only the Python library, or excuse me, Python executable, but all the modules associated with it. And because I'm a developer, I want to use Ubuntu. I don't know why that has to do with developers. They do love Ubuntu, though. So I want all of those file system layouts inside of there to look like Ubuntu, or Red Hat, or SUSE, or Gentoo, or whatever it is that I want. And I can use those tools to manage what's happening inside of there. I have control inside of that container. And this is important because it isolates, it separates what's happening inside of the container from what's happening outside of the container. So for us operations teams, how many times have we had arguments with our applications teams about, well, I see that you need lib xyz version 1.x.4.3.2.1, but this particular CVE says that we have to have version 2. Blah, 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 blah. And the applications guys say, well, we can't do that because, well, it's going to break all kinds of things. We have to go through months and months and months of testing and validation and all of these other things. And meanwhile, we're saying, but the auditors are coming next week. We got to make sure that we're in compliance. We have to apply this. Sometimes it's the inverse. Sometimes they're waiting on us. So by isolating those, I can remove that friction. So containers look very different depending on who you're talking to. If I'm talking to an infrastructure person, at the operating system level, it's nothing more than process isolation. It's not virtualization, it's isolation. And importantly, it's a shared kernel model. From an application perspective, it now gives me the ability to write code that executes on my laptop, hand it to my teammate and have it execute on his desktop, hand it to the QA team and it executes in the data center, hand it to the deployment team and it executes exactly the same in the hyperscaler or in the private cloud or wherever I happen to be running from. I eliminate the it runs on my machine problem, which is a huge problem for both developers and operations when we encounter problems. So how is this different? Virtual machines, if you look way down inside of the hypervisor, are nothing more than processes themselves. But there's a lot of additional things that are layered on top of a virtual machine. So we have, at the very basic level, we're restricting the things that that virtual machine can do at the hypervisor level. We don't want hypervisor escalation issues or anything like that. And we also have a whole kernel inside of there. It's a virtual machine. It's a virtual motherboard with virtual BIOS and virtual SATA ports connecting to virtual SATA drives that have an entire operating system. It has everything it needs inside of there. I don't have to worry about it. But somebody has to love and care for and feed and patch that entire operating system. A container, on the other hand, is just the application. Sometimes there's some other things inside of there, but really what we care about is the application. And when I say sometimes other things, it's tools. Maybe I start with that base Ubuntu image. Well, the Ubuntu image has a bunch of tools inside of there. Things like ls. Do I need ls if I'm never going to go into that container and actually execute ls? Not necessarily, but it's there if I do. So my container is the application and its dependencies. And I can deploy these to any compatible operating system. I can take that container, that Linux container, and have it run on any Linux operating system with a compatible kernel. And I know that it's going to work. Same thing with Windows containers. With my Windows container, so long as it is running on a compatible version of Windows, I can pick it up and I can move it and I can deploy it repeatably and reliably and know that inside of there, the same thing is going to happen each and every time. So from a slightly up-leveled, right, from a slightly less micro, more macro level, what we're looking at is virtual machines provide the highest level of isolation, full separate kernel. Containers provide process-level isolation. But the advantage is a container is often only anywhere from a few hundred kilobytes to a few hundred megabytes, which is not to say they only have to be that size. I've seen containers that are well above 100 gigabytes in size. Whereas a virtual machine is almost guaranteed to be multiple gigabytes. There's a whole operating system inside of there. And not only that, I have to worry about things like, well, the next slide, which this is not what the slide I thought it would be. So I'll skip ahead. So I have to worry about things like movability, portability. I can't take, sorry, Amy, a VMware virtual machine and move it over to KVM. I can't take a KVM VMware and move it over to Xen. I can't take a Xen VM and move it over to VMware. There's transformation processes that have to happen there. So instead, with a container, again, all I need is that compatible kernel. All I need is that base Linux or that Windows so that I can then take that container and move it around to wherever I happen to need it to be at. These are Red Hat slides, so of course we cheated and we have Red Hat Enterprise Linux here at the bottom. But it works with any Linux. So I'll jump back a couple of slides here to cover the one that I skipped over. So why is this important? For a long time, way back at the beginning of this, I started by saying that when the business says I need to deploy an application, that usually ends up wholly owned by operations. There might be some development team internally or a vendor externally, and Josh used to have a great slide in one of his presentations with the wall of deployment, where they package up all that code into something that looks suspiciously like a hand grenade and then lob it over the wall. And we operations guys jump on that grenade, we figure out how to deploy it, how to maintain it, and we do so. But now we can isolate that. Now we can ensure that when we get that container image, it is exactly how they have presented it. We don't have to do any modification. We can simply bring it into our container environment, deploy it, and run the application. And if something goes wrong, we can work with our development teams. We can work with our vendor teams in order to figure out and fix what that happens to be. Now I'll skip back ahead. So where do we go with all of this? An individual container is great. I always like to use the example of Microsoft SQL Server. How many of us have deployed SQL Server? What's the fastest you've ever deployed SQL Server? Like an hour and a half? It always takes forever to deploy, and I've never understood why. It's doing something. I don't know what that something is, but it's doing something. If I take that and I put it into a container, now I only have to deploy it once. And inside of there, I can configure whatever I need. I can pick that up and move it around. I can copy that and have two instances. And they are both going to be exactly the same inside of there. I can attach storage. I can attach all of the things that I need to that SQL Server in a container instance and not have to worry about, well, did this particular Microsoft patch get applied to that host server? It's inside of the container. It has everything it needs. I only need that base server. And it takes as long to deploy as it is to pull down that image. So seconds, minutes, not an hour plus. And that doesn't include all the data, all the configuration, all of the other things that I have to do after I finish with that next finish. So an orchestrator allows us to now treat these containers the same way that we do a virtual machine in a cluster. Applications themselves are made up of, particularly when we're talking about service-oriented architecture, when we're talking about microservices, tens, dozens, maybe hundreds of different components. And each one of those might have multiple instances. I always like to use the example of WordPress. Andrew's Cupcakes. I sell the best cupcakes on earth. So I'm going to start a WordPress blog to talk about my cupcakes and to help me sell cupcakes on the internet. And when I first start off, maybe I can run everything in one WordPress instance with one database instance. I've only got a few hundred customers a day. But as word of my cupcakes starts getting around, my website starts slowing down, starts coming under siege. So with a container, with an orchestrator, I can simply go in and say, well, we need 5 more instances of Apache and a load balancer. I deploy those containers. It takes a few seconds to instantiate those. Now I can balance my traffic across there. Well, now my database is getting inundated. I need to deploy a Redis tier. Okay, well, maybe I need tens or hundreds of Redis instances to help cache all of those database queries. So my application can grow both vertically as well as horizontally as needed. So an orchestrator provides us that ability of saying, I need to deploy 100 containers. Just make it happen. And it looks at all of those resources available, and it schedules them, and it makes sure that everything is communicating, talking, connected the way that it is supposed to be connected. So let's take a look at Kubernetes. So you've probably heard that there are many different orchestrators out there. As little as 2 to 3 years ago, there was 3 that particularly came to mind for a lot of people. Right? So Mesos, Kubernetes, and now I'm forgetting another one, Docker. Kubernetes has, by and large, become the front runner by every measure. We see it in something like 80+% of organizations, and even the organizations that have others also have Kubernetes. So let's talk a little bit of what does an application inside of Kubernetes look like. So first, we start with our container image. This is that base image that has all of the files, all of the things associated with my application or with my process. So Python and the modules and my code are inside of that image. When I want to run that image, it instantiates a container. We create a copy on write snapshot on top of that, so that way I'm not modifying anything in that base image, because I might need to make 2 or 5 or 100 different copies. So I create a copy on write snapshot, and then I start Python. And that is now my running container. In Kubernetes world, we have a third level, the pod. A pod is nothing more than 1 or more containers that happen to be correlated. The example I tend to use here is, think of MySQL. MySQL itself is a database, but maybe I want to have a side pod that does things like, hey, every 6 hours, connect in, quiesce the database, and spit out a backup. That's all it does, just periodically doing that. So it's 2 containers that are related that I want to deploy together always to accomplish some sort of task. So if my applications run in these pods, and I schedule those pods across nodes, well, now I need some other things to make sure that that happens. So in full disclosure, this diagram comes from OpenShift. OpenShift is Red Hat's enterprise Kubernetes deployment, so we take upstream vanilla Kubernetes, and then we add some value add services inside of there. So from our perspective, this is everything that you'll need to do a successful Kubernetes deployment. But there are some things that are not part of a base deployment, and I'll point those out as we go. So the way I start talking about this slide is to look at the far left in that big square, big rectangle that says master. This is a service. It's not an individual server. It's not an individual virtual machine. Right? It's a service that is a collection of those to provide something to the rest of the cluster. This is where my applications teams, where my operations teams interact with the cluster. And it provides things like authentication authorization. It provides things like a data store. This is simply to track the status of the cluster as a whole. If you're familiar with VMware, you can think of this as being like a vCenter. We have a scheduler. When I say I need those 100 containers deployed, the scheduler looks at those resources, figures out where to deploy them at, and then tasks those out to the nodes, which is in the middle there. Health and scaling, keeping track of whether or not that process is doing what it's supposed to be doing. If the application team defined a health check, hey, is it up? Is it healthy? If not, okay, restart it. And scaling, hey, I have 5 instances of Apache. They're all running at 80+%. It's time to deploy 5 more. In the middle, we have our nodes, quite simply compute resources. This is where my pods get scheduled to. I can add and remove nodes from the cluster as needed to support the workload that I have going on inside of there. So this is core Kubernetes. This is really what it does. But we also need some other things in order to be successful. A registry. This is where I store my container images. It can be an internal or an external registry. So that way, when my application team creates a new version, we push it to the registry, and then we can quickly pull that to our nodes to do updates to my application instances. Persistent storage. How many of us have heard that containers are ephemeral? Containers are ephemeral. Remember I said it creates a copy on write snapshot? When that process ends, when that container is destroyed, so is that copy on write snapshot. So if anything inside of there is also destroyed. So how do I persist data? I said MySQL earlier, right? Well, MySQL stores its data under var lib MySQL. I attach a volume to that location, and that is now managed separately from the rest of the data. If you're familiar with Cinder, right, OpenStack Cinder, same principle. So I need persistent storage. I have a service layer. This is very simply how my different services can talk to each other. So that when I deploy my great Cupcake website, I can have my Apache tier simply say, hey, I need to talk to Redis, right? Redis.application.local. Doesn't have to know anything else about it. The routing layer. This is how I get in and out of the cluster. So that when my external customers come to andrewsgreatcupcakes.com, it knows to send it to the Apache tier or the load balance tier. And then down at the bottom, of course, being able to deploy across any infrastructure. This is one of the great benefits of containers. It abstracts that underlying infrastructure, that operating system, and makes it transparent, makes it so that I don't have to worry about it. So one of the things, and I'm going to go a little bit faster through this section because I know I'm running out of time. So one of the things that I like to talk about with regard to containers, and one of the greatest advantages, is the ability to take best practices that we operations teams, that we understand and try to implement as we go forward, and being able to make them repeatable and consumable by anybody and everybody. So the operator framework is a set of tools that we can use to create these codified best practices systems. It's been adopted by the CNCF. It's part of their incubator phase. CNCF is the guiding council or the guiding board for Kubernetes itself. So what this does is it allows us for an application to define every phase of the life cycle of that application. So ranging from how to install the application all the way out through which metrics are important, how to tune, how to adjust based off of those metrics. The example I tend to use here is something like, again, MySQL. DBAs are generally a pretty smart bunch, even though they're kind of a grumpy bunch. No offense to any DBAs. And there's a reason for that. Because, well, we want to be able to control what's happening in the database. We want to ensure that data is consistent, right? It's been written. We don't have to worry about partial page writes. Does anybody know the term page tear or torn page? It's bad memories. So what they do is define as a part of the operator framework each one of those things. So things like, in order to do a backup, you have to execute this command to sync the database. After that, you want to pause it while we execute this command. After that, we want to unfreeze the entire database. I want to look at these particular metrics. These are the important metrics for how my database is monitored. And based off of those metrics, the tuning phase, I want to take certain actions. We can take all of that and we can put it into an operator. And then the advantage here is when my application team says, hey, I need MySQL, instead of going out and grabbing any generic MySQL or going out and just doing it themselves, which is what they do a lot of times when we deploy into hyperscalers or something like that, instead they're getting something that is already best practices, something that is going to have all of those things for it that follow it and move with it, that take advantage of all of that best or all of that tribal knowledge that has been codified. So at the end of all of this, why are containers important? We want to enable success for the business. That's what we really care about. We want to ensure that the business is successful. Now, to us operations people, a lot of times that looks like saving money. To applications teams, it looks like faster deployments, more bugs fixed, more features added. But ultimately, we all have the same goal, enabling success. So there's 3 things that I want you to take away from here. 1, containers are nothing more than a new way of deploying applications. It's the same application, it's just inside of a different mechanism for pushing it out to our servers. 2, applications have changed. The way that we deploy, the way that we manage, the way that, well, we see and interact with applications has fundamentally changed as a result of things like cloud native, as a result of things like the hyperscalers. We want to be able to provide those services on premises. We want to ensure that our applications teams are able to get the things that they need from us, not just from elsewhere. And finally, we want to continue to remain or continue to pursue automation. Remember, a good system administrator is a lazy system administrator. All of that being said, thank you very much. I do appreciate your time today. Please, if there's any questions, I know Josh has a microphone. I'd also like to take the time to say thank you to the NewOps team, so Splunk, the DevOps Institute, and of course, Rundeck. Thank you. Brain no working. So, thank you.
Awesome. Thank you, Andrew.
Do you want me to go first?
Yeah.
So yeah, anybody has any questions, just please raise your hand. We'll come around you. I had one though. So in operations, a lot of it's about keeping control of what's going on, right? So it was bad enough when we had developers just shooting war files at us on an increasingly faster pace. But now we're talking about this container, which could be anything from a mono service, could be just a single service, or it could effectively be almost like an entire operating system. It could be all kinds of services, tools, and libraries in there. So what are the kind of best practices today, and kind of where are things going in terms of being able to have security visibility and kind of management control and audit capabilities to make sure that all the stuff's flying around, that things are staying under control?
Yeah, so phenomenal question, thank you. So first and foremost, Kubernetes intrinsically supports things like quotas, right? So I can only define that you're allowed to consume this much CPU, this much RAM, this much storage, et cetera. And I can even break that down into different types of storage. So for example, you only get 10 gigabytes of gold storage, but you get 1 terabyte of bronze storage, if I so choose. In addition to that, that orchestration system itself will aggregate all of those logs. So if my Java process is running, maybe it has a 2 gigabyte heap, okay, great, right? It's generating all of these logs. I can take all of those and I can funnel them into other systems. So that way I can do aggregated log analysis. I can help with remediation and all of those things, right? Remember the operator framework? I can take advantage of operators to proactively, right, before anybody even knows something has happened, right, to take action based on those. So from an audit standpoint, aggregated logs. From a monitoring, managing resource consumption, quotas, as well as other things. So there's many different monitoring metric systems available. Prometheus is the official Kubernetes one, where you can surface out all that information, again, to take action if you so choose, et cetera. Did I miss components of that? I know there's like 5 different components.
What about what's in the container?
So what's in the container is largely left up to the application itself. So we can define things like liveness or readiness and liveness probes. So that application developer can maybe have an internal script, something as simple as a bash script, that gets executed periodically, again defined by them, that says, hey, this application is still up. or this application is no longer functioning. We need to kill it and we need to restart it. So there's a lot of things that can happen at that level. There's also a number of things. So open tracing is a project where you can trace every single API call as everything goes through, which there is several now that are integrated directly with the underlying Kubernetes orchestrator. There's a bunch of different ways of doing that. It really depends on how high or how low you want to get into that.
Hey, so maybe this is goes into what containers is. This is more of a DevOps question than I think containers can help with that. There's a little bit of contradiction, I guess, of the DevOps model with developers and operations. I'm an operations guy. That you want to collaborate with developers and to kind of bring them closer to what your environments are. Yet you still want to abstract or have a representation layer for what your environments are, what your production environments are.
Yeah.
So you're still kind of, operations is taking control of that, yet you have to collaborate with developers in that sense. So can you speak to a little bit of that kind of contradiction on how operations people can maintain control over the operations, yet collaborate with developers to kind of give them access, and maybe containers is the way to kind of bridge that gap?
Yeah, so the way that I typically address that is, generally speaking, an application team really doesn't know, doesn't understand, doesn't care what the capabilities of the underlying infrastructure are. So one of the ways that I describe this is, what is a platform 2 application, right? Monoliths, old school, right? What one of the analyst firms refer to as mode 1 type of applications, right? Where it's a monolith. Whereas platform 3 is next gen, cloud native, et cetera, right? Mode 2 type of operations. So from an operations team, what's the difference here? A mode 1 platform 2 application expects the infrastructure to be infallible, right? It expects it to always be there. If the network blips, if the storage goes away, if something happens to one of those 2 servers, the application just falls down. A platform 3 application, on the other hand, compensates for all of that. It knows that the infrastructure fails all of the time. These were applications born in things like AWS, where there is failure all of the time. So one of these is super expensive. We've probably all made our careers off of, myself included, developing, deploying, architecting, designing, supporting as many nines as we can possibly get. They're complex, they're hard. That's why Josh had a beeper in like 2013, right? Whereas when we look at a platform 3 application, the development team, the application team takes on all that onus. They bring that complexity up to the application tier. So one of the things I like to talk about and advocate for is, well, there's a happy medium. What if instead of designing an architecture for 6 nines, we design it for 4 nines? And that application, instead of assuming that everything is going to fail, it's, well, I can assume that these things are going to be okay. These things are going to provide some resiliency or some redundancy, so I don't have to put as much effort, complexity into that architecture. So now we take the operations team saying, hey, I've got 4 nines, 5 nines, whatever it happens to be, but there's faults in these areas. And the application team can say, okay, I can compensate for those faults. And now they can work together to make those things better. So it becomes the best of both worlds, where now it's a less complex application, a less expensive infrastructure, and everybody is happier, theoretically.
So I got a quick one.
Okay.
So I think most of us have probably run VMware for a long period of time. How does adopting containers, being a VMware administrator, like in 90 seconds, like what's that start to look like for us?
So when I was worked for a storage vendor, one of the biggest things that I always argued with storage teams about was you have to let go of the provisioning process. Why are storage admins so stodgy? Right? Because storage is expensive. Because storage, when it breaks, it's a catastrophic event. So they get that request in, they want to know where every byte lands on every platter of every drive of every array in the entire data center. But the problem is, as I said before, applications have changed. It's no longer I provision that storage volume and it exists forever and I never touch it unless something goes horribly wrong. It's now, well, I'm developing, I'm testing, I'm qualifying, I'm deploying code constantly. Right? DevOps, we want to have continuous deployment. So if I am controlling every volume, every piece of storage that is happening out there, I can't keep up. Suddenly I become a bottleneck. So I have to let go of that provisioning process. Virtualization administrators, very similar. I don't need containers to do any of this. A lot of organizations, a lot of applications have yet to adopt containers because I have the automation, I have the pieces in place. Does anybody know HashiCorp Packer? Right? I have all of these tools in place where I can deploy everything to a virtual machine. I just need to let go of that provisioning process. And instead, as an operations person, as that storage admin, virtualization admin, instead of focusing on, I need to make sure this lands in the right place the first time and never touch it again, instead it's, hey, I saw you consumed a terabyte of gold storage, but you're barely touching the IOPS. Can we move this down? Let's move down to silver, or let's move down to bronze, working with the application team to figure out what their requirements are and what's the best way of providing that service.
Anybody?
I think there was one back here next to the column.
Being a Windows virtual server kind of guy in the ops department, I don't have a good understanding of how containers would fit or how you would apply a container. If I were to write an application, how do I containerize something?
Yeah, so getting started with containers, more or less. So at the base level, a container is just like installing your application. It's just in a separate, isolated environment. So if I were to go out and start with something like Docker, when you want to create a Docker container, you have a Docker file. And what that defines is, how do I install my application? Whether that's on a Linux system, whether that's on a Windows system. So if it's a Windows system, it's simply, hey, do an MSI exec, blah, 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 blah. If it's a Linux system, maybe it's one of the Red Hat derived ones, right? I use yum install or RPM install, whatever that happens to be. I install my application to that container, I add any configuration items that I need inside of there, and then I simply package it up. So that process varies slightly depending on which technology you're using and a couple of other things, but that's more or less the core of it. If you want to, you can also instantiate a container. Docker run Red Hat. And you will be inside of what looks like a Red Hat system, even if you're running on an Ubuntu system. I can use the same tools that I'm familiar with to install my application, to configure my application. I exit out of that container, I leave it, and now I can package it up and distribute it just like before. So there's a couple of different ways. I would definitely recommend checking out either the Docker documentation, so simply docker.com. They have a link for docs up in the upper right, and there's a getting started. You can also go to, I'll plug OpenShift, which is a Red Hat product. You can go to learn.openshift.com, and there's a whole bunch of labs that you can walk through. It literally takes 6 seconds to get dropped into a live environment, and it'll walk you through every one of those processes.
And if I'm not mistaken, the Docker engine is in Server 2016 and beyond, right? I think they actually included it in there. So you just have to go into your services and enable it.
Yep.
Yeah. Maybe the in test environment, just throwing that out there.
Yeah.
All right.
So in my experience, application developers really are not trained or pay attention to security. So how do you address, if you're handing over the security components to the container, how do you address security in the container world?
Yeah, so there's a couple of different ways to look at that. So one of those is literally things like network access. You know, applications guys don't care about firewall rules. If I'm using a container, I have to explicitly enable every single port that it wants to access. So they have to, they don't have a choice now. It's, I want to access on port 443 or 8080 or whatever. When I deploy that container, I have to explicitly turn on that port. So that helps in that respect. As far as implementing, or I'll say better coding practices, that's one of those DevOps philosophy and practices types things of integrating the security team, ensuring that the testing, the hopefully automated testing that's happening incorporates some security functionality so that as it rolls through those processes, it just becomes a part of that. But yeah, there's kind of two different aspects. One is better code. Well, I can't make anybody write better code as much as I would love to be able to do that. But we can, through those controlled interfaces, as well as things, Kubernetes uses overlay networking, right? So through those overlay networking interfaces, implements microsegmentation, et cetera.
Yeah, and there's like a kind of a sub-conversation of the DevOps movement called DevSecOps. And it's really all focused on how do you take security scanning and pen testing and things and get it into the pipeline, either at build time or kind of in running in test environments. And it's very kind of, well, it's pretty new. I mean, the word's been around for a while, but this kind of movement's really about a year old or so. So there's a lot of videos online, all-day DevOps, or I think it's an all-day DevSecOps thing as well too. But there's a lot of people talking about just doing this, and it really boils down to pulling those automated testing tools into the pipeline. So developers' code has to run through these kind of gauntlets before it gets out.
And
So to add to the question about the security controls, how do you monitor or log those kind of Docker and containerization components? Because they get spun up so quick and get shut down so quick if something does happen.
so the question being, how do you monitor, how do you, the actual components of the orchestrator or the application components?
The application model.
So generally speaking, going back to liveness readiness probes, right, we use that to ensure that it's actually running the way that we expect it to be running. Beyond that, so let's look at something like Kubernetes. I have a deployment config, and I tell that deployment config, always ensure that there's 5 instances of Apache running. So it uses those liveness probes, make sure that all 5 are up and running. If one of them goes down, it'll restart it. And then again, through aggregated log systems, I can watch the life cycle of those all the way through. I'll jump back 1 second to your question again. There's also a number of tools that help to monitor and ensure that the packages inside of those containers are up to date. So again, looking at systems from like Red Hat, so we use things like Buildah, B-U-I-L-D-A-H. No comment on the name. To do things like, and I can give a security rating. So, hey, this was built off of this base image, and it had these packages applied to it. So all of those are the current patch level, so I give it an A. A few months go by, right, it now sees that, hey, there haven't been any of those security packages updated. That base image is now out of date. So now it's been demoted down to a B or a C. So I can easily see which packages have had, or which container images have had security packages applied. There's a bunch of different suites out there to do that. So
Awesome.
Did that answer your question?
One more quick question there, we're running over time.
I don't
Because
want to
I think you
interrupt
can
lunch.
smell what's cooked.
You're all the same to me, lunch.
That's all right.
Okay, hopefully I won't be too long. But building off the last 2 questions, having been in operations for 20 years, the primary responsibility is a lot of accountability. Operations is accountable for everything. And what I've seen so far in the DevOps environments that I've seen has been the developers have loved all the new toys that they can get, but don't want any of the accountability that goes with it. How do you, and maybe this is more for the DevOps conversation that's going to come up later, but how do you address and shift and get that accountability shifted to where it's supposed to be when operations has been responsible for it for so long and on the hook for it?
So I think you're absolutely right of that becomes a larger organizational issue of, as I said before, right? Operations teams are measured typically by efficiency. Application teams by how quickly we can get new features, et cetera, out there. And yeah, when things fail, it typically comes down to the operations team because the applications team is only focused on the next version. How do I develop? How do I get that over there? So by changing, working at the management, senior management level, wherever that converges, so that everybody is managed by the same thing, or excuse me, measured by the same thing, is one of those hugely beneficial things. That being said, I know these 2 guys right here are.
I was going to say our talks are going to actually
itching.
touch on some of that too. So yeah, you'll definitely get that with my talk and some of Damon's as well. All right, we're gonna stop the Q&A. He's going to be here for a little while. Okay. If you have any like Kubernetes or container-based questions, just like with the last one, write them up, put them on here.
And maybe 2 sides. If one is maybe if you're already getting involved in container, what's your next challenge?
Yep.
And if you're not, what's your big question? So if you can all just take a second before we run for the food, just write down a thought and let's stick it under the containers, and we'll be getting to that later.
All right, so your 3 pieces of information that you need right now. If you're desperately needing the restroom, again, go through where you entered. It's on the left. If you're desperately hungry, the food's right over here, right on your left. It looks delicious. Make sure you take some time to spend with say hey to the sponsors who joined, and get your thoughts, questions, or answers up onto the board. We will reconvene just before 1 o'clock, and then we'll kick off the next series of talks. Okay? Thank you very much, Andrew.
Thank you.